Hi, welcome to identifying proportional relationships. I'll get started here. So we're going with the main idea is talking about proportional quantities as equal ratios. So a ratio is simply a comparison of two quantities. Something like 4/5. That's a comparison, usually using division. Like that is. A ratio can be expressed as a verbal description with a colon or as a fraction. So we're talking about 4:5 or 4/5, right? Okay. Complete the statement to describe proportions, then decide if the two ratios of each table are equal, if they are right a proportion. So a proportion is an equation saying the two ratios are equal. And what we have here is So what we have here is a proportion. Okay, so are they equal? Is it the proportion then is to say that 12/10 is equal to 18/15. How do we know that the two of these are equal? Well, what you could do is you could cross multiply. You could multiply 12 times 15, and that's 18, and 10 times 18, that's 180. Both those cross products is called 180, so you know that the two are equal. Okay, so what we could do is we could say, well, I know that this is 120, and I know that that is not 120. I don't know what it is, but I know it's not 120. So, are they equal? No. And by the way, how did I know that this was not? Because 4 times 8 is 32, so the product of this ends in a 2. It would have to end in a 0 for it to be equal, so I know that's not the case. Okay, so then the last one here, if I have that product is 40, and this product is also 40, so yes. So the proportion would be 5/20 is equal to 2/8. Okay, next, complete the statements to describe the proportional quantities. Proportional quantities are always the same. They're always the same ratio. And so, if we look at this here, let's see what we got here. The ratio $6 for 4 slices of pizza and $3 for 2 slices of pizza are part of a proportional relationship because we know that 6/4 is equal to 3/2. Write each pair of descriptions as ratios. Place an X in the appropriate column to show whether the quantities of raisins and nuts are proportional. Okay, so let's go with this. 1/2 is not equal to 3/4, so we know that that's not proportional. We get 1 to 2 is equal to 3 to 4. So we'll go 2 to 3. So 2/3, is that equal to 4/6? And yes, it is. So it is proportional. And then we have this one, 8/6. Is that equal to 12/9? Well, yes. What? 8 times 9? That is 72. And 6 times 12? That's also 72. So they are in proportion, and you say, yes, they are proportional. Okay, so I'll keep on going here. The main idea for simplifying main idea, we're simplifying to test for equivalent ratios. So we'll complete the steps to show how to determine if 3 pairs of quantities are proportional. So what we're talking about is how do you test if three pairs of quantities. So I don't know, like 2/3, 4/6, and 6/9. Are they all proportional? Well, let's see. We have to write the ratios for the pairs of values. So we have to write the ratios. And we simplify the first two ratios. And then we will compare we have to compare those first two ratios. So for this example here, I would simplify these two. And the first one's already simplified. 2/3, and this simplifies to 2/3, and they are equal. So now let's simplify the third ratio, and we will compare the ratio to the first two. So compare, we will compare the third ratio to the first two. So let's take that third ratio. I can simplify 6/9 to 2/3 again, and I compare these. And yeah, they're the same. So there's all three are proportional. You see, that's what that's all talking about right there. Now we will complete the table to show the quantities are proportional. And we have 5 apples and 2 pears. Well, let's see. This one's already done for you right here. So we'll do the 20 apples and 8 pears. So that would be 20 apples and 8 pears. And we would divide both of them by 4. Simplifying that, 20 over 8 equals 5 halves. You divide them both by 4. And then we have the 10 over 4, and 10 over 4 is equal to, divided both by 2, that's equal to 5 halves. So all of those rates are all the same. See, that's what they were saying about right here. Show that these quantities are proportional. They are because they are all the same fraction when they're simplified. Okay, number 7, complete the statements to show how to use the cross product to see if ratios are equivalent. A cross product is the ratio of the first term in one ratio and the second term in the other ratio. If the cross products are equal, the ratios are equivalent. And that's what I was mentioning before. So use the cross products, show why these are proportional. So if I take 3/4 and 9/12, and I'd use the cross products. 3 times 9 is 36, but also 12 times 3 is 36 as well. They are both proportional then, because 36 is equal to 36. And then we have 5, 6, and 10/15. Why is this not? Because 15 times 5 is 75, and 6 times 10 is 60, and 75 is not equal to 60. Okay, now getting to the main idea and graphing to determine proportionality. So describe how you can know that two quantities are proportional from a graph. This is how you know. Two quantities are proportional if their points make a straight line, if their points make a straight line that goes through the origin. And that origin, I should do a better job of spelling that nicely. Oops, come on now. Stop that. I just want to erase that word origin right there. It's just not, I'm just not feeling it. Can't write that sloppy. origin, and that origin is the point 0, 0 on the graph. So draw a graph of quantities that are proportional and graph quantities are not proportional. So one that's proportional, well, it's a straight line that has to go through the graph. So if I do something like this, so that's up to and over 2, up to and over 2, up to and over 2, up to and over 2. So I'm drawing, and this ends up being a straight line that goes through the origin. You know what? I could do a better job than that, and I'm about to. I'm going to get my ruler. I don't know if you can see me get my ruler up, but I'm going to do my ruler. And I'm going to do this like a boss right now. Boom. Oh, I got to stop at the origin, though. There we go. And let's go with something like this, where we have a point here, up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3, and something like this. So this still makes a straight line. I'm about to show you, but it does not go through the origin. Oops. I just biffed it right there. Okay, let's see now. So there we go. That one does not go through the origin, so that one's not proportional. So there's a couple of examples. Okay, let's go with our key terms here to finish this off. And a proportion, that is an equation stating that two ratios are equal. Also, it could be, I'll write an alternate thing here. It could be, what's a proportion? It's two equal fractions. Okay, so there you go. Now, the next one, proportional quantities. Okay, that is quantities. Oops. Quantities. Quantities that are always in the same ratio. And a ratio is really just a fraction. It's just a fraction. But what I should also tell you is it's a comparison that shows relative sizes. So a comparison of two quantities. Okay, so there you go. That is what you got to know about, oh boy. That is what you got to know about, what do we say here? This is proportions, ratios. Look at all this stuff I have here. But we're talking about proportional relationships. That's it. Thanks for watching.